You have an infection of some sort. These bacteria are infecting you. And when you have a bacterial infection, you have lots of them. And some of them may have a little mutation. And in this case, I've indicated that mutated gene with a little squiggle of black in their DNA, that somehow in the process of copying, some of the letters in their DNA got changed, and that change changed their outward appearance. Because remember, genotype determines phenotype. So here, it gave them sort of an extra strong cell wall. They've got maybe an extra layer of protein around them. And what that means is the same chemical that kills all of these guys does not kill the ones who have an extra cell wall. So as you're taking an antibiotic, and it's merrily chugging away and killing off these non-resistant bacteria, it's not killing off the antibiotic-resistant bacteria. Now remember, we said when you're taking an antibiotic, your bacteria are still multiplying. So every bacteria that's there is still undergoing binary fission. But what's happening is that which ones are being killed? The ones that are not resistant, the ones that are what we call sensitive to the antibiotic. But they're all multiplying. So pretty soon, who's got the lead? The antibiotic-resistant bacteria. Now, one thing you should know. Antibiotic resistance is not always an all-or-nothing game. It's not. So, if you give these resistant bacteria enough of whatever the antibiotic is, or you give it for long enough, eventually you may start to kill them too. It's possible. It may just take longer. It may take more doses, and you still may not kill them in the same numbers that you're killing the other guys. But eventually, you can kill them too. Usually. Not with all of them, as we saw in the film. But with a lot of them, they're resistant. They're not completely impervious. Impervious means completely unaffected by. So they handle that antibiotic pretty well, but if you give them enough of it, eventually you may start to kill them too. Okay. So why is this happening? Because the ones that are not resistant to the drug are the ones that are dying. The ones that aren't dying, the ones that are resistant to the drug, survive in greater numbers, and because their resistance is genetic, it's a matter of a gene that they possess, they pass it on to their offspring. And since bacteria reproduce asexually, their offspring are largely identical, not exactly always because of mutations, but they are largely identical to the parents. So this is natural selection at work. Straight up, straight out, natural selection. If you keep exposing an antibiotic, if you keep exposing bacteria to antibiotics, they will develop resistance, period. Because who dies first? Which bacteria die first? Not only the ones that aren't resistant, the ones that are, if we think about it in less than black and white terms, so if we think about it as sort of a spectrum, I like spectrums, they're more realistic. So, very weak to very strong. So, no resistance whatsoever to, I'm still going to put in almost, totally resistant. So if we're on this spectrum, yeah, the ones that die first are down here. You're killing off the weakest. I mean, that's natural selection, survival of the fittest, survival of the strongest. In this case, survival of the most resistant. So when you're exposing bacteria to an antibiotic, the first to die are the ones that have no resistance whatsoever. And you keep moving up. They keep getting harder to kill. And, you know, there may be some that absolutely will not respond to that antibiotic. And then you have to have, well, you have to have either an immune system that will take care of them before they multiply out of control, or you have to have another chemical, another something that you can kill them with. Okay, questions, comments? Do you see how bacterial resistance could develop, how it could build, this idea of building? That you're really selecting for the strongest. You're pushing natural selection in the direction of the strongest bacteria. And a lot of it, you know, in the film they talk about the fact that it's not just bacteria, it's genes that are contained in bacteria. And very often, those genes specifically protect them against a particular chemical. Now, did the bacteria think in its little brain, bacteria don't have brains, they're unicellular, did it think, oh man, if I could just be resistant against that? No. It was lucky. It was darned lucky. You have a miscopy of a few letters, and suddenly a bacteria has an extra thick cell wall, or that bacteria is making some chemical in its cells that neutralizes an antibiotic. It's fantastic. So how do you build better bacteria? If you wanted to build awesomely resistant bacteria, nobody wants to build resistant bacteria. How could you do it? What would be the best way to do it? How could you build super resistant bacteria? Remember that we live in a world that has lots of different kinds of bacteria, and it should. We said your body's an ecosystem. You've got bacteria that are going to help you by digesting parts of your food, by actively eating stuff on your skin, competing for space with bacteria that can make you sick. You want as many of those good bacteria on your body, in your body, as possible, because they're crowding out the bad bacteria. This is kind of like hawks and coyotes competing for mice. If you want to starve out the hawks, double the coyote population. No mice and rabbits left for the hawks to eat, the hawks starve. You want good bacteria on you and in you because they crowd out the bad bacteria. So we've got this world of lots of different bacteria, and if they're just going along doing their thing, the only thing that's affecting the frequency of genes in their population is random chance. What do we call that? Do you remember? When random chance affects the frequency of a gene in a population? Genetic drift. Good. Yeah, they're just drifting along. They're mutating here. They're mutating there. What forces evolution's hand? What forces natural selection? Hardship. Making life tough for an organism is what forces that organism over multiple generations to change, to adapt. Well, what if we kind of bathe the entire world in antibiotics? What would that do? What if you just sort of gave out small doses of antibiotics all the time? Oh my gosh, yeah. You'd kill off all the weak bacteria. Oh, wait a minute, that's not a good idea. That's a terrible idea. So, bathing the world in antibiotics, because wait, remember, bacteria can exchange information even if they're different species. So notice that little black gene just popped up in the spiky bacteria. Oh, that little black gene just popped up in those bacteria. And that gives them that same extra thick protective coating because they've gotten information from this species of bacteria. They've shared genetic information. Now they're all a little bit more resistant. So then what if we bathe the world in antibiotics? Oh, that wouldn't be so good.
I'm agreeing with that.
Huh?
I'm agreeing.
Yeah, you're agreeing that that would be bad. Yes, it would. It would be very bad. So when we put a lot of antibiotics in the environment, what you get is more resistance. You get more dangerous bacteria. Remember in the film they kept saying every time that you use an antibiotic, it becomes less effective? This is why. This is kind of like showing somebody a copy of the test. Hey.
Pardon the interruption.
So this is akin to me saying, hey, kid, here's a test I'm going to give you tomorrow. You want to look this over for a few hours, and then I'll take it back, but then I'll try to give it to you and see if you can pass it. Of course you can pass it. You went and looked up all the answers. In essence, when we give low doses of antibiotics to bacteria, now remember, this is a metaphor. Bacteria don't have brains, they don't have eyes, they don't have mouths. They're not thinking, they're not trying to become resistant. But when we expose bacteria to an antibiotic, the ones that are resistant are the ones that survive. So when you come back with that same antibiotic the next time, it's just a little bit tougher to kill them. Okay. Questions on the process of how antibiotic resistance arises. Okay, so hearing no questions, let's talk a little bit about what you can do as an individual to not make this problem worse. Okay, so what are things that, so I'm hearing a couple suggestions. So somebody's saying, well, don't overuse antibiotics. Somebody's saying, well, let your body fight off infections on its own. What else? Take the full dose. That one is huge. That one is enormous. If you have 10 days of antibiotic, guess how many days of antibiotic you should take? 10. If you feel better at day 5, do not stop. You are building better bacteria. It endangers your life. It endangers my life. It endangers my child's life. I'm absolutely serious. I'm vigilant about this. I yelled at a pediatrician last winter. He got a little bit defensive. We had to go to the urgent care. My daughter we're sitting there at dinner, and I said to my husband before dinner, her eye looks weird to me. There's something going on with her eye. And it just looked a little bit, I don't know, I couldn't even describe it. By the time we finished eating dinner, like 30 minutes later, her entire eyelid was pink and swollen, and she had little bits of pus coming out of her eye. I said, she's got pink eye. Let's go. So there's a pediatric urgent care just down the road from us. So I showed up at urgent care. Some nice pediatrician who we've never met, this was not our normal pediatrician, said, oh, yeah, that's bacterial pink eye. There are two kinds of pink eye. There's viral, which is caused by a virus. Antibiotics do not work against viruses. And there's bacterial pink eye, and that's caused by a bacteria that gets into the eye, into the little tear duct, and infects it. He said, here are some antibiotic eye drops, and it says on the label that it's a 7-day course, but if she's looking better by day 2, you can just go ahead and stop them. And I said, wait a minute. That's a terrible idea. And he said, what do you mean? And I said, I'm sorry, I teach biology. I do a whole thing on antibiotic resistance. You don't really tell people to do that, do you? And he said, well, yeah. I said, you're building better bacteria. He got a little bit defensive. He said I shouldn't criticize pediatricians, and there were bigger problems in the world. So needless to say, she got 7 days worth of antibiotic eye drops. You don't mess around building better bacteria. Neither should you. So finish the course is a huge one. So finishing your course of antibiotics is a big one. Somebody else said don't overuse antibiotics. What does that mean? How would you be overusing antibiotics? Using them when you don't need it. Yeah, exactly. So we said there are viral infections, there are bacterial infections. I always ask my doctor. And it's hard when you're 16, you're kind of not quite in charge yet. When you go to the doctor, like you probably, I think probably most of you still have a parent coming into the doctor's office with you to ask questions. But you can start to take a more active role in your own health care. When you're prescribed an antibiotic, I always, when they say blah, 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 I say, well, wait, okay, is this viral? Then I'm just going to ride it out. If you have a viral infection, the only thing that you can do is rest and drink lots of water. I mean, that's all you can do for a viral infection. An antibiotic does nothing against a virus. Viruses work in a totally different way. We don't even think, they're not even really living things. They're a whole different sort of thing. They're not considered a living thing by the classical definition. Bacteria are. So don't overuse. Okay, don't overuse. Let's add one more thing to don't overuse. I want you all to go home. Who here has liquid soap in their house? Okay, so do I. I want you to go home and I want you to look at the label. And I want you to see if it says antimicrobial. Soaps that are antimicrobial, and there are lots of them, what does that mean? It's antimicrobial. Kills bacteria, it's against microbes. Things that are labeled antimicrobial actually have small doses of an antibiotic in them. You want to build better antibiotic? You want to build better bacteria? Just keep feeding them tiny doses of antibiotics. Antimicrobial soaps have a substance in them called triclosan. It's an antibiotic. Now, it would be really interesting to see how effective triclosan is at this point against normal household bacteria, because we've been exposing them to triclosan for 10 or 15 years in small doses in things like soaps and antimicrobial kitchen sprays. Seems like a terrible idea. So, to add to don't overuse, don't use antimicrobial soaps, not soups, soaps. Soaps and sprays. And again, this is one of those things where you guys really aren't in charge of your own household yet. You're probably not the one who's shopping for liquid soap. You're probably not the one who's buying kitchen spray. But you can put in a word with dad or with mom or with grandma or with aunt or whoever is the person who's doing those things in your house. Hey, don't use the antimicrobial version. Now, what about something like this? Hand sanitizer kills 99.99% of all germs. It's the active ingredient. Do you know? No, it's not triclosan. I would not have it in my room if it was. Alcohol. It's ethyl alcohol. So as far as I know, as far as anything I've ever read or researched, microbes can't develop resistance to something like alcohol because it kills all living cells. It's not targeting microbes. It's not targeting something in their protein code. It's not targeting some chemical pathway of theirs. It basically dries them out. Basically sucks all the water out of them. You ever notice how alcohol dries your hands? If you use a lot of alcohol hand sanitizer, your hands get dry. It's sucking the water out of your cells. What's that thing that all living things have to maintain? Steady state. What do we call that? Nice balanced environment, not too hot, not too cold, not too wet, not too dry. Homeostasis. Yeah. Well, part of that is your water balance, and you have ways to maintain your water balance. You can pee more, you can sweat more, you can reserve water, you can stop peeing, you can stop sweating. Bacteria got none of that. You dry them up, they just die. And it doesn't matter that you can't develop a resistance to that. You suck all the water out of a bacterial cell, it's dead. So for surface disinfections, this is great. Could they have, in a case like Addie's, could they have filled her lungs with alcohol? No, that would kill her. So it's not, you can't use something like an alcohol-based bactericide inside the body because it'll destroy your cells, and that's a problem. But, for surfaces, if you want to disinfect a table, which is not a terrible idea. I mean, you're all leaving bacteria on your desks right now.
Don't they usually use those for cuts, though, in alcohol?
Yeah, we do. And it does. Now, there are doctors and nurses and paramedics who will say, don't use alcohol or hydrogen peroxide on a cut because it damages the tissue around the cut. And it does. Now, if I'm out in the middle, if I'm in the garage and I'm working on something and I bust open a knuckle and it's got all kinds of dirt and grease in there, which is the bigger risk? A bacterial infection, because I don't clean it up immediately, or doing some damage to the additional cells around the cut? Probably the bacterial infection. So I alcohol my cuts if I'm working on something. Huh? For cuts, I have. If I don't have anything else, like my daughter and I were out a few weekends ago. It was really nice. I took her out to a creek on a Sunday, and we're stomping around in the creek and picking up rocks and finding bugs and chasing whatever. And she got some little cuts. She fell on the rocks, whatever. She got some scrapes. Just not knowing, how much fecal material's in that creek, how much anything else. On closed skin, if you have a good immune system, you're probably good. But on open skin, I want to get those sterilized. And I do keep alcohol hand sanitizer in my car, just plain alcohol. And she doesn't like it. She knows it stings. I said, hey, you know what? We got to clean those up. And so I just give them a quick wipe down with a little bit of alcohol. Does it do a little bit of damage to the skin? It does. But I'm just kind of weighing the risks. Would I use something with triclosan in that cut? No. No. The less we expose bacteria to antibiotics, the weaker they all are collectively, because we're not killing off the weak ones. Okay, so what's the best way that you can sanitize your hands? Soap and water. Soap and water and friction. Seriously. That will remove 99.99% of all germs. Soap, water, and washing them for long enough. We at my house now, because I have a child who's into every stinking thing you can imagine, which is great, it's good. But she's making what she calls bird spaghetti out of pine needles and stagnant water, and there's probably bird poop in it. And she's out there stirring it with her hand and trying to feed it to the dog. Ew. Poor dog. When she comes in the house, she needs to be washed. She actually needs to be hosed. But we do a thing. Okay, she comes in from whatever filth she's been into and says, I need a snack. Okay, great. You got to wash your hands first. When you wash your hands, we literally at my house now sing a song. Do you know how long you should wash your hands? ABCs. And we finish it up with, now I know my hands are clean, next time won't you wash with me? So it's like her funny little hand washing song. You need to wash them, and you need to rub them well, and you need to rub under all the surfaces. Does anybody have a nurse who they live with? Anybody live with a healthcare professional? Nurse, anybody who works in a hospital setting or a doctor's office setting, nurse, doctor, nurse's aide, any of those things. And I think this has changed. Growing up, I had a couple aunts who were nurses, and they were not allowed to wear any rings at work. No rings. Do you know somebody who's a healthcare professional who... No rings, right? Still? Good. Why?
Because the bacteria can hide underneath of it.
You can't wash effectively underneath a ring.
And they have to wash all the way down to the...
Well, when people are going into surgical settings or they've been in caring for somebody who's got a known bacterial infection, yes, they're washing up to here. In surgery, they're washing nearly to their armpits going into a situation like that. Washing your hands is the most effective thing you can do to prevent infection. Just simple soap and water. It's nothing high tech. It's nothing fancy. It is as simple as it gets. Now, what else can you do? So, okay, don't overuse them. Finish your course. Don't overuse antibiotics. Don't use antimicrobials. Just wash your darn hands. There's one other place that we use a lot of antibiotics that most people don't think of. So we've talked about, you getting an antibiotic when you don't really need it, or borrowing somebody else's antibiotic because you're feeling a little bit bad, or using an antimicrobial surface cleaner. Where do we use most? Where is the most crazy use of antibiotics in this country, you think?
Farms.
Farms. We have a lot of antibiotics in hospitals, and very often that's for a good reason. We have a lot of infections in hospitals. So we do want to be using antibiotics in a hospital setting. Now, you still want to use them cautiously. You don't want to overuse them. You don't want to bathe the whole hospital in antibiotics, because then pretty much every bacteria in the place is resistant. But yeah, we do use them a lot there. The place we use them that people don't think about is farming. So it was discovered, I think it was in the 1950s, that gee, if you fed chickens just a little teeny little bit of antibiotics in their feed, they grew faster and stronger. They got bigger faster. Well, if your chicken gets bigger faster, it means it comes to butchering weight faster, and you have to give it less feed to get the same amount of gain, and that's more money. It's fantastic. It was like a miracle. Same thing with other forms of livestock, with pork, with hogs, with cows. You give them little tiny, it's called subtherapeutic doses. So a subtherapeutic dose is a dose that is less than what's needed to combat the disease. It's less than therapeutic. So, subtherapeutic doses. Ooh,
And they use it a lot in China.
they do. Subtherapeutic doses, antibiotics in agriculture. So it was fun. It was fantastic. It was like a miracle. Now, this practice is like, you'll see chicken in the store that says no antibiotics or hormones, and I think it's actually now illegal in this country to give antibiotics to chickens, to routinely put it in their feed. Now, if you have a sick chicken, you can give it an antibiotic. If you're a farmer and you have sick animals, you can and you should use an antibiotic. But this routine use of subtherapeutic doses, little teeny tiny doses, what are you doing if you're giving somebody or something tiny little doses of antibiotics all the time?
Weakening their immune system.
Well, you're not weakening their immune system, but you're building better bacteria in their body. So you're not weakening their immune system. Their immune system is going to remain their immune system. But you are building better bacteria in their body. Well, where do chicken bacteria come out? In their poop. You poop out lots of bacteria. I mean, that's why we have all kinds of things like, you don't play with poop. It's full of bacteria. And some of it was good for you when it was in your gut, and some of it is dangerous for you when it's out here. But most of it, you don't really want spread around the world. And if you're giving livestock little subtherapeutic doses of bacteria, you're building better bacteria. And this is a huge issue. I don't know, we'd have to look up the status of the legality of using subtherapeutic dosing with hogs. I'm pretty sure they still do in a lot of places. Using antibiotics, and the one physician said it in the film, they are a miracle. I mean, people used to routinely die of childbirth from infection. People used to die of simple infections from cuts. People used to die of infected teeth regularly. Many of you, if we were living in a completely pre-antibiotic world, many of you would not have survived to this point. You wouldn't be sitting here. We wouldn't be having this conversation. we don't want to go back there. Okay, so let's talk about some of the possible futures for this. The future, so this is a bacterial plate. You can take a little plastic plate, you have an agar mix in the bottom, and you can actually buy a little tiny disc, a little dot of paper, it looks like the punch out from a 3-hole punch, that's coated in an antibiotic. It's called an antibiotic disc. And you can put little antibiotic discs into a plate where you grow bacteria, and then sweep the plate with bacteria, incubate it, and see if the bacteria will grow up to the edge of the antibiotic disc. And what you see, if the antibiotic are sensitive to the bacteria, or if the bacteria are sensitive to the antibiotic, what you see is this. What you end up is something that looks like this. So each of those is a little it's an antibiotic disc, and they've cultured this plate with bacteria from something. What do you notice? Some of them have a big bare space around them. So the brown, this stuff is bacterial colonies. Where you can see through to black, to the background, that's where no bacteria grew. So, this drug, is that effective against these bacteria? No, not really. Neither is this one. This one is losing its effectiveness. This one so far is the best we've got against this particular bacteria. I don't know what this bacteria is. I don't know what these drugs are. But years ago, I met a man who had taught high school biology for 35 years, and he said when he had started teaching, and he had started teaching in the 70s, he always did bacterial culturing with his biology classes. And he said I would give them 3 antibiotic discs. One was traditional old penicillin, I forget what the others were. And he said, and I gave them 1 mystery disc, too. And he said, over the years, what we saw from year to year, the bacteria made more and more progress on the antibiotics. He said there was always, they never gained ground on the mystery disc. They never gained. So 30 years on, the mystery disc was still an effective antibiotic. You know what the mystery disc was? Garlic. Garlic. Garlic's a great antimicrobial. I have been known to take a slice of a fresh garlic bulb and slap it on a cut under a Band-Aid. It's a great antimicrobial. It stings a little bit. Why couldn't bacteria develop resistance to garlic? Well, here's the answer. Standard antibiotic. You know how many active ingredients it has? 1. So tetracycline, guess what it's made of? Tetracycline. Amoxicillin, guess what it's made of? Amoxicillin. It's a single chemical. It's purified, it's synthesized, it's 1 chemical. It does 1 thing against a bacteria. Something like garlic, so wait, active ingredient 1. Something like garlic, how many active ingredients do you think garlic has? Hundreds. Garlic, who here has eaten garlic? It's wonderful stuff. I should have brought some in. I grow lots of garlic. I love garlic. I'm all about garlic. Garlic has hundreds of chemicals in it. The flavor that you get from garlic is the result of hundreds of chemicals. And depending on what kind of soil it was grown in and how wet the weather was that year and when it was planted and what other things were growing near it, the mix of those chemicals is slightly different. Well, if it's never quite the same twice, guess what? You can't develop resistance to it. So there are people who are looking at things like garlic and essential oils from plants. And because those things change, they have lots of active ingredients. They're a cocktail. They're not a single chemical. And looking at those as the future. So, interesting point of thought. You will have a quiz tomorrow. You will be able to use whatever notes you made. I will not be here. You will be with a sub. The sub's instructions will be, you get that 1 sheet. You're going to turn that sheet in with your quiz because I'm going to grade your notes from today. And then Tuesday, we'll finish up with another short film about antibiotic use in agriculture. I know many of you will not be here then. So we're going to kind of finish up. If anybody has not turned in their biology book, they need to make sure they do that. And that's all. Okay, that's it.